one. The reason I wanted Spencer to come talk to us is I feel like, how many people here have heard of Kubernetes? Like the entire room, right? How many people here have played with Kubernetes at all? All right, but maybe a third of the room. How many people are running it in production? Yeah, maybe like 6 people tops. So out of 100 or so. So like, I feel like a lot of people want to get to the point where they are running it, and it feels sometimes kind of unapproachable. Like this is a very big problem. There's a lot. When you run through Kelsey Hightower's Kubernetes the hard way, and you're like, all right, I figured this out. I got this. Oh, production. And it seems like a pretty big gulf. And so I think one reason I wanted Spencer to come talk about this to us is because it is not an absolutely enormous enterprise use case, but it is a real use case that he's actually using. So that way you get to hear about some of the pros and the cons and the things he learned and whatnot of actually using it in a real use case, but without all of the incredible complication that could be possible. So I'm excited about this Kubernetes case study. So without further ado, do we have your mic on?
I don't know.
Let's try turning it on.
Usually.
Okay. Try
Hello?
saying. There we go.
There we go. That's good.
Awesome.
That
Thank you,
works
Tad.
okay.
So without further ado, give it up for Spencer Krum.
Woo! Thanks, Bridget. We're still working on my laptop over here. Don't worry, folks.
Oh, I thought I saw slides.
There were slides. The problem today is just Linux in general.
Oh, okay.
Classic.
Joe, can you?
There's dozens of us.
There's
I know,
dozens of us.
FreeBSD.
Some of us are wearing Andy Domeyer's name tag for reasons. Imposter. Okay. How many of you are using Linux on the laptop? You're not alone. It might
Dozens
not be,
of us.
It might not be the year of Linux on the laptop quite yet. In 1999.
Oh, we're
Exciting pictures.
cooking with gas now.
This is exciting.
All right, everyone shout out your favorite xrandr command.
I gotta say, I took a job 2 months ago at Microsoft.
Wait, really?
Really?
What?
Did you not know I work at Microsoft now?
What?
But that's not the whole story. I took a job at Microsoft. They issued me a Mac, and they said, get people to use Linux on Azure. And I was like, 2017 is weird. Okay. So it's funny because, here we go. It's funny because, everybody says, oh, you work at Microsoft now. Do you have one of those Surfaces? And I'm like, no. Was I supposed to? So, in any case, it looks like you're sort
Well,
of.
we
had it
gotta-
a minute ago.
Well, I mean.
Oh, you have to be
it's
ready for the
this
demos.
Projects,
All right.
yeah.
But Spencer, if you read his bio on meetup.com, which I assume you all read diligently, but if you read it, you may know he works for IBM, which is awesome. But he's not telling us about official IBM projects here. So I'm actually really interested in how this ties into your work with IBM.
Yeah, we do
I
that
think
a
that's
lot.
cool. We should hear about that a little bit.
I don't have a what? Oh, there's a session manager for sure. It's where you go to TTY1 and then you just start X. No. Anyways. All right. Thank you, Bridget. Thanks, everyone, for bearing with us. Linux and Firefox got it done together. This is a Kubernetes case study of sorts. So, who am I? Well, my name is Spencer Krum. I'm a developer advocate at IBM. I'm focusing on containers, infrastructure, software, stuff like that. I've been an open source fan for a really long time. I've been working with open source for a long time. I'm really excited to be part of that. IBM has a rich history there. I'm new to Minneapolis. I moved here in April. I was in Portland for a couple years, and I was part of the DevOps scene there. Thanks for having me in your city. It took me a couple months to get out here, or to get out specifically to this meetup, because it's just I felt like I had to get my apartments done and get a car, stack wood for the coming winter. By the way, what was last week, right? No. No. Not cool, bro. Anyways, I'm on an active friend hunt coming to the new city with no new friends, so feel free to hit me up. We'll make something happen. Okay, so this story starts at Dreamhack, which I'm wearing their t-shirt. I'm happy to shill for Dreamhack any day. They're really dope. So Dreamhack has been around since 1994. It's an esports event. They brand themselves as a digital festival. And we were in their Sweden event, my buddies and I, and it's a very small town. It's 2,000 people in this town, 3,000 people in this town. And then for one weekend, it's like 10,000 people because there's every gamer in the Northern Europe just rolls into this place. And they set up their LAN party and they do their esports tournaments and they take over like multiple aircraft hangars. It's really quite a thing to experience. It's super fun. And we were there because IBM let us kind of explore esports for a little while. And so we're sitting at the bar after the event, and because gamers had taken over the city, the bar, which was a sports bar, like this is Jönköping, Sweden. There's a giant Tom Brady behind me, of course. The bar had decided that it would become an esports bar for the duration, which is a smart move. And so, if you know kind of a little bit about the gamer scene, what is kind of big these days is not just playing the games, but watching them on Twitch. And so Twitch sort of ends up, it's a video platform that you can watch other people play video games on. There's a lot more to it than that, but that's enough to get started. And so the bartender was making sure that they had 60 or they had a bunch of big screen TVs in this thing, making sure that all those screens were showing competitive esports because that's the audience who was there in the bar. The problem that he had was that running esports has a lot of pauses. There's naturally a lot of pause. And so there'd be some Counter-Strike, it would be exciting, and then it would end in a few minutes, and there would be some announcers talking, and then like a commercial break. And those breaks can be 10 or 15 minutes. So almost every third drink, this guy would have to go to his laptop, which is perched on the bar, so like in the middle of the bar, and he would have to, poke around on twitch.tv and try to find someone who's actually playing Counter-Strike, click on that, repeat, rinse, repeat, rinse, repeat. So my friend and I are sitting there thinking like, well, so we're going to solve this problem. We need computers. So, how do we build something that, it makes it, So we're kind of thinking like, if you're familiar with the NFL has NFL Red Zone, right? Which is an ESPN channel or a Super DirecTV channel of some kind that on Sunday specifically only shows you segments of games where like stuff's getting real. So you'll have like anytime someone's in scoring position or inside the 20-yard line or whatever. And so you can constantly be watching the action. And so how can we build something like that, but for competitive esports? And I do promise we will get to Kubernetes. So for those of you who can see, I know a lot of you can't. For those of you who can see, this is what competitive Counter-Strike looks like. There's a lot going on, and there's trying to do red lines. There's which guns are enabled. There's like a couple different kinds of score going on. If you think this is bad, you should see Overwatch. But we're thinking, we discussed this for a while, we think about it, but then there's this other game that you might have heard of that has one number in the upper right-hand corner. Who knows what game we're talking about? PlayerUnknown's. 5 people. This is PlayerUnknown's Battlegrounds. That's the slide that didn't work. Yeah! PlayerUnknown's Battlegrounds is kind of a phenom game that came out this summer. They sold something like 5 to 10 million copies in a summer, pre-release. It's not done yet. They had a dev team of like 2 people, and now they have millions of dollars. And they're just like, what do we do? For some context, like this thing grew faster than Minecraft. Like this is a crazy game. It's a crazy popular game, and it only has one number to keep track. So let's talk a little bit about what this game is. Again, it's called PlayerUnknown's Battlegrounds. That's kind of long, so everyone just says PUBG. So think Hunger Games. It's 100 people. You're one of them. You're in a plane. You're cruising over a map, and then you dive out of the map, and then of those 100 people that land on this island, only one can win, right? And this game built on what was there was Arma 3 and an H1Z1 mod that kind of built on this form. PlayerUnknown, like from the name, actually worked on those mods. That's why it's kind of his okay, I'm done with you guys. I'm going to build my own game the way I want it to. So you start out on this map. This map is considerably larger than any map you'd see in Counter-Strike or Halo or something like that. It's more like a World of Warcraft style map. It would take a really long time to get from one end to the other, even with vehicles. So you land. It's permadeath. There's no respawn, and there's a lot of kind of There's a lot of finding. You land with no equipment, so you have to source all your own equipment or take it from other players. And there's no respawns when you die. So it's this kind of enclosing circle. And in order to make the enclosing circle even more real, there's literally an enclosing circle. So that's what it looks like when you win. And then at some point after you've been on the island for a couple of minutes, this circle appears. The white circle and then the blue circle. And you have to be within the white circle before a certain timer runs out or you start taking damage and eventually die. So while the number of people is always shrinking as people meet each other and somebody wins, the space you're allowed to occupy shrinks as well. Until in the last couple minutes of the game, you're in a very small little field area and only one can survive. I'm not going to show any gameplay from the video or from the, because it is a little violent, and I just didn't. When you show Twitch or you show violence like that, like it can be. I just didn't want to upset anybody. So I'm happy to show it on my laptop afterwards, but there won't be any video clips in this presentation. So what's Rotisserie, right? So Rotisserie is this app that we built that is designed to just be what that bartender needed for this game. And it says like, okay, well, the most exciting part of this game is when somebody is below like 25, like whoever, and then because before you're above 25, like when there's more than 25 people alive, like everyone's just running into houses and bushes and picking up gear and hiding in their bush and then hiding in the bathroom and then there's a few more minutes of driving and then there's 10 people on a hill and it's really exciting. So what we did is we kind of make this app that runs in the IBM cloud. Woo! We made this app that runs in the IBM cloud and does this. And it goes even further by saying we're going to make sure that we're showing you, the viewer, the stream that whoever on Twitch is the closest to winning, who has the lowest number in the upper right. And so the application that we built looks kind of like this. There's kind of a one-page, like Spencer-style JavaScript, not very good, app that makes a request. You just get served some like static HTML and JavaScript. That JavaScript makes two requests. The first is to the API server, that's kind of the main app, and that gets like a data blob of like who's alive and where and all this stuff. It's sorted. So you can identify what the name of the streamer is that's the closest to victory, basically. And then you make another one, and you grab Twitch's iframe player. So Twitch has an iframe player that's totally within the terms of conditions that like you can just embed on your web page or whatever. And it doesn't have all the full features of Twitch. At this point, Twitch is quite the platform with chat and emotes and notifications and messages and stuff. But using that iframe makes it really easy to kind of switch between people because you just like jQuery, just like switch it out. Yeah? Okay, so the question was about specific Twitch. We'll talk about, the question was about specifically what does Twitch streaming look like, and we're going to talk about that in just a second. Okay, so the functional way that app works, I guess we could go through it right here, is first we hit the Twitch API to get a list of streams. Then we fork off a bunch of processes that use an open source project called Livestreamer to pull those streams and as a recording. Then that utility doesn't have a stop, so we actually do a sig term on them because YOLO. Then we use everyone's favorite FFmpeg to take a single frame of that 4-second clip or whatever. Then, Then we actually use image magic to grab that little 30. Yeah, you thought image magic was bad, but then we used JavaScript, so yeah. No, you should read this code. Like, Spencer's not allowed to write JavaScript anymore. Anyway, there's a lot of people on this team, okay? It's not all my fault. Okay, so then, because, DevOps, we made a little Tesseract microservice. So Tesseract is sort of the standard open source optical character recognition, which is like take an image and return whatever text was on there. And so we just kind of compartmentalized that into its own little Express application. That's like a microservice. You can tell because it has a health endpoint. Mostly because I figured one day I would want to replace it with something better, possibly powered by like deep learning or something. Maybe Watson, I don't know. So then you call that out, and then what you end up with is this nice little array of tuples of stream name and number of people alive, and stream name and number of people alive. And it's really nice because you just sort of know whether the number is between 1 and 100, they're alive, and if it's anything else, if it's Robert, if it's blank, if it's Tesseract crashed, they're probably dead, or we didn't read it anyways, so they're not allowed to be on the stream. And so we end up with this application, which again, we're not going to show you until a little bit later. But there's some problems with that, and these are more about the the operation, like the software that we wrote, than the Kubernetes. So we're going to gloss over these problems and talk about the deployment. So the first deployments, of course, were on our laptops. Second deployments were on some kind of a virtual machine somewhere. Eventually, we kind of ended up putting it into the IBM Kubernetes offering. So IBM has a Kubernetes thing. It works kind of like GKE or whatever they have in Azure. You just kind of, button, and then you get a Kubernetes, and then you have credentials, and you can deploy stuff to it. And so we kind of made our own bespoke deploy to Kubernetes pipeline. And I'll talk you through a little bit of that like today. Yeah, for sure. You know what's going on is my mouse doesn't work. Really, Linux? What will? Boom. Thanks, whoever did that. Okay. So what we did is we wrapped, basically we had this application deployment pipeline, which has a lot of warts on it, but this is how we're running this application in production today. And so I wanted to talk about our makefile. So our makefile looks like this, and it basically just has a set of targets, I guess is what they're called. And the first thing we do is we actually scratch the like the short version of the git SHA of whatever we're in into a file. And so that introduces this limitation that you can't deploy from an unclean tree. You kind of have to deploy from something you committed. Then we go through and we run the, we actually go through this, we have a make image script that basically just runs Docker build across our 3 different image types that we have in our application. There's 3. There's one for this main Node.js application that does most of the work, one for the OCR microservice, and one that's just a packaged up version of Nginx so that it can serve static files like jQuery or the HTML or pictures or whatever. Then we go through and we tag those images, we push them into a Docker registry somewhere. Then we have a deploy that just goes through, and there's a little bit of complexity here. Yeah, so I don't know how other people are doing it, but who knows what env subs, it's probably hard to read. Does anyone know what env subst does off the top of their head? Right, it's an environment substitute. So you basically put environment variables into your shell or whatever's calling that, and then give it a file, and it replaces those instances with things. And so we use that on our Kubernetes deploy YAML so that we populate some things. And that makes it easier so when we're switching clusters, or I think we parameterize Docker registries to, there is a need, like this is your first lesson. There is kind of a need for something that templates out the files you will eventually emit to Kubernetes. You'll get there sooner than you expect, in my experience. Well, that was like the 3rd thing we did. Was there a question back there?
I was going to ask you if you ever use bash. So you check like in bash, you can like not bash, I think it's but like you can query see if a var is populated, and then you ever do that?
Yeah, so there's stuff. Yeah, there's default values in bash. Yeah, those aren't. Yeah. The point mostly there was to actually pull the rev file out of what we had, so that way we're tagging, because we basically tag every image on the git SHA, so that our Docker images, I guess, are tagged specifically with the git SHA of the SHA they were deployed on. So like we waste a ton of disk space and a ton of time doing that, but it makes the other thing easier to reason about, so it's worth it, right? So that's step 1. Okay, so and like this application turns out to be not super hard to put in Kubernetes. It's not super complicated. So we have 3 pods. I'm sure no one's ever shown you this. And so this top from the 3 dashes, which is the beginning of the YAML whatever, to the bottom 3 dashes, that's one deployment. And the deployment refers to a pod, and what that means is it'll actually end up starting some Docker containers. We do a little bit of stuff with this kind of configuration. I don't expect that you would have any trouble figuring out what to put there. Down here, we do some cute stuff with some secrets, which were supposed to be in my slide deck, but maybe we missed it. Is that what this says right here? No, I don't know. Well, anyway. So before you deploy these pods, what you should do is set up some secrets, and the secrets are not hard to do. Basically, you once again, like your standard Kubernetes thing is to write a little YAML file that looks like this, and then kubectl apply -f this file. And specifically what you put in that your OAuth token in base64 and your client ID in base64 is you take whatever like plain text secret thing you have and you pipe it through base64, and then you play with the new lines, because that will trip you up a couple times, because you need to make sure it doesn't have an extra new line in it. And it's very easy to do it. It screwed us up like 3 or 4 times, and still does. And then you just send that into Kubernetes, and then you pick it up on the other side back here with these value from secret key refs. And now the app has been given the ability, just by environment variables, to have access to some secret data. And there's 2 specific pieces of secret data we need for this application. The first is the API token we use to talk to the Twitch API, which has like informational stuff, like this is the number of streamers, this is how many viewers they have, that kind of stuff. And then the second one is a different kind of token, which is used by the live streamer utility to actually authenticate and then pull down the video stream itself. And the video stream itself used to be on Twitch, because there was a question about it. The stream used to be RTMP, which is a semi-open protocol from Adobe, and now is HLS, which is like an Apple thing. And as far as I can tell, like you can't really watch it with like VLC or FFmpeg. Like as far as I can tell, the only implementation of the HLS protocol is in the live streamer source code. And so that's part of why we're going through the machinations of like starting it and then p-killing it, because like there wasn't an easy way to get that out into a utility that like did what I wanted, which was record for 4 seconds and stop. Yeah, so there's 3 applications. Basically we're going to run 3 different Docker containers. This right in here or so would be where you would write like replica set, and we have occasionally set up replica sets like where we would run like 3 of the OCR microservice. So, and it would load balance, well, in a second it will load balance between them. But that's not like the long pole in the tent, so it's only for kicks. So, oh, there are the secrets. Yay, secrets, don't forget to do them. Seriously though, the new lines will screw you up, like no joke. 3 services. So after you set up some pods or deployments, you put some services in front of those. Everyone kind of says the same thing in the Kubernetes talks, which is a service is like a load balancer, which to me means nothing, because it's like, no, it's not. Sure. Specifically, this is a cluster IP, is maybe an easier way to understand it. You're gonna, when you create this at the top, right, with this service, you're gonna end up, like you might think of it, it might be easiest to think of it as like requisitioning a virtual IP inside your cluster. It's like a 10-dot IP that then something can be reached at, and the something is what you pick with this selector. So we're attaching it to a specific set of pods and Docker containers with that, and then we can reach it. And we do 3 of those because we have a static server that does Nginx, we have a static server that does, or a server that does the main app.js, and then we have this OCR service. Then we put an ingress controller in front of it. And so an ingress, early ingress controller looks something like this. And this is like starting to look more like a web front end, if you're kind of familiar with like your LAMP stacks or your LAMP stacks that got out of control, right? So what we're doing here is IBMesports.com. So it's called rotisserie ingress, and then we're doing some cool routing stuff, right? And if you've been writing applications, it's familiar to want to put the static stuff, right? You point that at the static pod, and you point the all, which is the API endpoint that you get all the information about the streamers from. You point that to its own pod as well. And at that point, the app started working with only 3 files worth of Kubernetes stuff. It was quite good. Everything was good. It was great. And then we were like, well, what about SSL? That's when things kind of came off the rails a little bit. And I actually learned quite a bit just today about how we got this working. And so, right. So there's even somebody here from it. Thanks, Let's Encrypt, for existing. Big shout out. Woo! And they're hiring. Woo! And they're not part of the Linux Foundation, in case that was a hang up for anybody. So Right, so remember how we deployed it to a VM first? Like, I'll just come clean with you. Like, we had a Let's Encrypt cert left over from that. So we just kind of shoved that into our ingress controller and called it good for like 90 days. But we knew. Okay, so like in Kubernetes, right? Like, really tempting the demo gods, but kubectl get secrets. Right, so if you run, there's two kinds of secrets in Kubernetes. The first is just an opaque secret or whatever, where you just shove random, like strings and stuff, passwords. And the second one is this TLS, where it has some concept of like what an X509 encoded PEM encoded thing is, right? And the ingress controllers are pretty slick because you can just attach those TLS circuit secrets to them, and they just get it done. So we had the right data because of the VM. So we just attached it, and we were up and rocking and rolling. But of course, all that did was whet our appetite for something that was more, in the Let's Encrypt way, auto refreshing, renewing, right? And so there's a project out there on GitHub called KubeLego, which has like 1,000 stars, and everybody's pretty hype about it. And it purports to do the heavy lifting of like, okay, well, the way you do SSL in Kubernetes is you attach your TLS certificate to your ingress controller. We'll run this YAML, and then it will do that for you. Solid. So like, let's look at what that looks like. It looks really good. This is exactly what you want. I want like one blob of YAML that says deployment, that references an image that I don't have to care about. Okay, that's just saying like it exists. Trust them. And then all the classic Let's Encrypt configuration. What's my URL? What's my all that stuff. Right. That's great. The problem we had was it did not work. Whoops. And one of the reasons it gets away with being so simple is because it gets quite clever. KubeLego. What it will do is the application that actually runs here takes advantage of Kubernetes like reentrant properties, I guess is what you say. Like things running inside Kubernetes pods can hit the Kubernetes API and make things happen. So in this case, what it'll actually do is it'll make more ingress controller. It'll make itself its own ingress controller, and it will make itself its own cluster IP. And so you're actually, even though you've only submitted one KubeLego resource to Kubernetes for creation, you actually have 3, or maybe there's more I don't even know about, right? And what ended up happening is out of the box, it did not work with the IBM Bluemix, or I guess it's IBM Cloud now. Sorry, we rebranded. It did not work out of the box with the ingress controllers that you get by default there. And so what we had to do was we had to kind of up our game around ingress controllers before it would automatically work with the KubeLego system. Does that sort of make sense? I think it does. So we had to get service about our quote-unquote load balancer, right? So I even have a file called get-serious.yaml. All right, so what we ended up doing was pulling the reference Nginx ingress controller thingy and copied a lot of stuff off GitHub and ended up throwing all this in there. We put our current, our slash, and our all, routed to the different things. There's no routes here for the OCR microservice because that doesn't need to be reached externally. It only needs to be reached internally, and pods can find each other through either kubedns or what we're doing, which is injected environment variables, which we can show in a second. And what you actually have to do is create not just an ingress controller that's been marked with this kubernetes.io Nginx class, but you have to come down here and actually create a deployment specifically of the ingress controller itself. I'm not of the ingress controller, of this is sort of the meat. The Nginx controller, or the ingress controller artifact itself doesn't really do anything. It just kind of holds data as far as I can tell. Whereas this thing, this actual deployment that has Nginx in a Docker container, that will actually pass packets around. And then it just sort of knows what to do because it watches the ingress controller for work. And then there's a bunch of stuff down here that you kind of hate that you need, but you do. So this one is a service, but it's of type load balancer, and that actually will requisition a public IP address. And then we can point DNS at that, and we tell it to pass port 80 and 443. And then somewhere in here, we tell it to do the rewrite from 80 to 443, except in cases of the Let's Encrypt like Acme challenge thing. And then we have these default HTTP backends, which we're pretty sure we can delete, but I didn't want to do it before my talk. And then there's some stuff that actually didn't even get copied, but we can open up the real one. Oops. that this is also, so there's a config map down here where you're just sending in some Nginx configuration options. And config maps work kind of like the ingress controller, that it just sits there holding data, and you can shift data into it, and the Nginx that's running in the pod will or in the deployment will actually go out and grab it and update it. All right, so let's like look at it a little bit. So the first thing to do is to look at like kubectl get pods, and then kubectl get rotisserie. Oh my gosh, this is going to be so hard without my mouse because I can't. Oh no. Oh, we're gonna try, team. Uh-oh. Well, maybe not. Anyways, let's go look at the website. That'll work. So we go to rotisserie.tv. This is what it looks. Once again, I'm not allowed to write JavaScript. But we have the little green check mark because Kubernetes or Kube did its job. This is what PUBG looks like. And you can see that this person, Fatboy Code, is at 19 and War Owl is at 20. And as you can see on the right, there is some lag time, right? Like it's not perfectly set up. And I don't want to show too much of this because I don't want it to become, a code of conduct violation or anything. But that's a 10-second look at what the game looks like. Oh, come on. You're killing me. You're killing me, Holmes. F5? No. Control F5? Well, I want to run the slides. We're going to make it, team. Okay. So it works. Yay. So what are some lessons? Well, one of the things I found with Kubernetes, having used it for a couple months here on a relatively, it's a low-key project with my friends, but we are trying to run it as a service, is there's kind of a lot of ways to win. Like we would often discover that stuff would work and then run with it, and then discover more stuff that would run with it, and then peel some layers back, learn some more stuff, and then run with it. And so you can have this app running without being 100% correct. There's a lot of, because you're doing so much just tagging YAML objects with like annotations and stuff, there's a lot of stuff that you will do that won't have any effect. And so there's not so much criticalness of getting it 100% right. It's not like every line in your YAML file needs to be correct. Like I was kind of saying, there's a lot of stuff in our YAML files that doesn't even have to be in there. Like all that health Z stuff you might have saw fly back, that's just like copied and pasted. And it's like you need it for Google, but you don't really need it for like when we're using it on the IBM service. When we started kind of having that reentrant property where things would create their own resources, that's when like the complexity went super hockey stick and it became very difficult to understand what was going on. That's where really inspecting it using the kubectl tool came in very, very handy. And then, because the first time we saw that was with SSL, like getting to the point where we had a kube Lego or we had SSL auto renewing, that's when things got pretty intense as well. Putting the commit in the image name was like good and bad. It was kind of nice just because it made it pretty easy to tell what was going on. Like we didn't spend a ton of time being like, well, which image has been deployed? Like we knew. But it did create some instances where we weren't behaving correctly, where somebody would and by somebody I do mean me, would like, well, I haven't pushed this code yet, but I'm gonna deploy it. So you honestly just commit anyways on your own little branch, deploy that, and then submit a pull request like, hey, can people merge this? I did deploy it, right? Like my preference would be to have an end-to-end pipeline where once it lands on master, the robots deploy it. But especially considering this is as much a learning as it is other things. Like when your game is tight, it's pretty easy to stick to like, I landed in master after it's been peer reviewed and then it's in production. But if you don't know that much about what you're trying to do and the stakes aren't very high, like our stupid esports app, like it would have been better to have a little bit more touch with it. I said it before, but it is so easy to screw up the new lines in your Kubernetes secrets. Like the next time, like when you're playing with Kubernetes and it's not authing right, or it's not, just go check your secrets. Check your secrets for new lines. Because of the way they get encoded, it won't be there. One of the ways, I can't exec on any of these pods because I can't type them out. But one of the ways to check is to kubectl exec pod name env and just run the env command, which might be a shell built in, and it will dump all the environment variables, which include things like the cluster IPs of all your services, but also all the secrets that have been injected. And it's really easy to see when there's an extra new line because two variables will have a space between them. And that became like something I would just do every time, like for a couple days after we refreshed the secrets, because like I became distrustful of it. Like we screw that up. It's really easy to screw that up. Also because they're secrets, right? Like at least right now, we don't have any kind of like a make file for the secrets. That's always somebody on their laptop trying to do it, and that introduces, because it's a human process, probably haven't done it too many times before, that introduces all these opportunities to screw it up. Just a second, I'm almost finished. And then kubectl exec is really dope. You can actually go to any pod that's running, like specifically Docker container, and run a command there. You can start a shell, you can dump environment variables, you can ping if you installed ping, you can check to see that files are getting set up. Like you can really get in there and debug why that thing can't do the thing you want it to be doing. Our future plans kind of have this idea that, like, because K8 jobs exist that like run to completion, it'd be kind of cool to make it so that rather than Node forking off a bunch of like just sub-processes that do it, maybe like submit those as Kubernetes jobs that record screenshot, crop, and then OCR, maybe that, and then they go in some queue somewhere. That'd be a fun thing to do. We're not actually doing a perfect refresh with the makefile right now. Like there's some stuff that we should probably be deleting that we're not. Like I said, I want to get the full deployment pipeline where it's only once someone that's not me merges to master, and then robots pick it up, generate Docker images, refresh the registry, deploy. And then we have a lot of boilerplate, right? Like I think we're kind of at that, like we added Kubernetes YAML until it worked, and then we're happy with it. But now we need to start pulling stuff out and making sure there's nothing on there that doesn't need to be on there. We also want to flesh out, like maybe we could do this with CSGO or Overwatch or something. And then Twitch released a new API called Helix recently, which is combined with something they're calling extensions, which isn't super fleshed out yet, but it's possible maybe this app doesn't have to use the iframe player. Maybe we could be more integrated with Twitch or an app, and people could log in with their Twitch ID, or maybe there's some opportunity there. Anyways, thank you so much. My name is Spencer Krum. I'm happy to answer those questions.
I do have a mic for questions, which might make this a little bit easier.
Hi. So yeah, I thought it was kind of weird, frankly, that you use base64 for your secrets. Did you consider using just GPG and generating a public key for when you're and then just because the secret has this, is the secret stored? I don't know that well. Is it stored on the pod, or is it stored?
Right. Okay. So it's not that you're
And
base64
GPG,
encrypting it, right? You're just encoding it to base64 so you could submit it to the API without having any corruption. Right. So it has to be base64, and then it's stored in the Kubernetes like secret storage thing, mumble, and then exposed completely plain to certain pods. And there's a whole RBAC system in Kubernetes 1.8 that gives you finer grain control. But yeah, that step of base64ing is not about secrets. It's about like making sure that you mean what you want. Because the other thing is like your kubectl apply-f, all those files, you're just submitting these data structures to the API. It's not like that's all you're doing. Does that make sense?
Yeah, I think there's some contextual things I need to think about.
Yeah. I don't no idea if Kubernetes encrypts those secrets at rest. Maybe.
As of 1.9, it does.
Yeah, I think earlier version statements, I want to say about it.
Okay, so the peanut gallery is claiming that Kubernetes 1.9 will encrypt secrets at rest. Are there any questions?
That's what I've heard. Someone at Microsoft.
Okay, well, thank you very much. I'm going to show the app on my laptop. I didn't want to show it for everybody. Feel free to come up. I'll give you a look at it, or we can go through my YAML after. And thanks so much for having me. And I'm serious about that friend hunt. Don't be shy.
Thank you, Spencer.